So in this lesson, we're going to learn about two keywords that we frequently hear about on the SAT or ACT when it comes to probability. And those words are probability with and probability with or. So let's start with the probability with and. Anytime you hear an and probability, you are going to apply this formula right here. And that is to say, probability of event A and B both happening can be calculated by taking the probability of event A and multiplying it to the probability of event B. Now that may not make a whole lot of sense, so let's try this example here so you'll have a better understanding of how to treat this. So let's read it. The probability of rolling an even number on a six-sided dice and, keyword, flipping a tails on a coin. So if you have a six-sided die, numbered 1 through 6, you can see that there are 3 even numbers. So we have 2, 4, and 6. Keeping in mind the formula for finding the probability, we know that we have 3 favorable out of a possible 6. And then on a coin, you have 2 sides. You either have heads or you have tails. So if you want tails, the favorable one is this one. So 1 out of 2. Now to set this up using probability terminology, we can rewrite this as find the probability of rolling an even number and a tail. And to make this even more relevant to us, we'll do it this way. We'll say the probability of even times the probability of tail. And we know the probability of rolling an even. We have 3 possible outcomes for even numbers out of a possible 6. Multiply that by the favorable for a tail is 1 out of 2 because a coin has 2 sides. And then this is simply arithmetic. We're just going to multiply these. 3 times 1 is 3 over 6 times 2, which is 12. And yes, of course, we can simplify this. You have to simplify every fraction. So this is going to be 1/4. So the probability of rolling an even number and a tails is 1/4. If you wanted this as a decimal, you could say 0.25, or even as a percent, 25%. All right, so let's then move on to the OR probability. Just like the AND probability, the OR probability also has its own formula. Now it is as follows. The probability of event A or event B happening is calculated by taking the probability of event A, adding it to the probability of event B, and then subtracting the probability of event A and B happening. This is known as the overlap. And we could talk about this more, but that's not the point of this lesson. Just know that this is the formula that you need to use if you have an OR probability. So let's actually put this into practice by answering this question right here. Let's read it. The probability of rolling an odd number on a 6-sided die. So we want an odd number on a 6-sided dice, or keyword, flipping a head on a coin. Remember, a 6-sided die has 3 odd numbers, so we have 3 over 6, and a coin has 2 sides, so there's only one head, so that's going to be 1 over 2. But again, let's set this up using the correct nomenclature. That's going to be P odd or heads. It's going to equal probability of odd plus the probability of heads minus the probability of odd and head. So the rest of this is just plugging in numbers. We know that the probability of rolling an odd number is 3 out of 6. Why? Because there are 3 odd numbers on the 6-sided die. The probability of flipping heads is 1 over 2 because there's only one head out of 2 sides. And then we're going to subtract the probability of rolling an odd number and a head. So remember, as we just learned, and means multiply. So here we're going to be multiplying the probability of rolling an odd number. Once again is 3/6 times rolling a head is 1 over 2. So once again, arithmetic. In fact, we can simplify this 3/6. That's just 1/2 plus 1/2 minus 1/4. So this becomes 1 minus 1/4, which simplifies to 3/4. Or if you wanted the answer as a decimal, it would be 0.75 or if you want it as a percent, it would be 75%. So the key takeaways here are if you hear the word and, you need to simply apply this formula, multiplying the two probabilities. If you hear the word or, you're going to add the two probabilities, but then subtract the overlap from them. And that concludes this lesson.